Welcome to the deep dive. Today we are looking at a device with well, a genuinely intimidating name.
It's a bit of a mouthful, yeah.
The Thor H-ASI-AMP managed 16-channel ASI distribution amplifier. So before we get lost in the acronyms, let's just nail down that first part. ASI.
Right. ASI is the asynchronous serial interface. It's basically the standard that broadcasters use to, move compressed video all around their facilities.
Okay, so we're diving into how this specific box takes one of those feeds and reliably splits it 16 ways.
And our job here is to figure out what makes this thing more than just a big fancy splitter. Because when you're running these huge distribution networks, you need absolute precision.
Unyielding precision.
Exactly. So
Yeah.
Our mission is to find those key technical features that guarantee signal integrity and, intelligent management for you, the learner.
And right off the bat, you can see this is a heavyweight platform. It's built for scale.
For sure. It can run as a simple 1x16 distribution amp, or DA, or you can use its dual inputs to run it as an intelligent managed 2x16 DA.
It's all about guaranteeing that high output across a really complex network.
And that need for precision, it really starts with the signal integrity itself. I mean, if you split a high-rate video stream 16 times, noise and degradation can build up fast.
So how does it fight that?
It uses something called application-specific reclocking circuitry. It's designed, specifically for these multi-rate ASI signals.
And the source material is great here because it doesn't just say clean outputs. It actually gives us proof.
Yeah.
It points to a spec about lower residual jitter, specifically 180 picoseconds at 270 megahertz. For someone who doesn't live in a broadcast control room, why is that number, that jitter number, the real tell for quality here?
Well, jitter is essentially just timing error in the signal. So low jitter means those very clean outputs are guaranteed.
Because the circuitry is cleaning it up.
Yes. The reflocking circuitry basically resets and tidies up the signal before it's multiplied. Think of it like restoring the stream to its original perfect state every single time. It prevents that digital mess that causes problems down the line.
Okay, so we know the signal quality itself is protected on the hardware side, but what happens when that clean signal leaves the box and goes out into this, huge network?
And that's where the intelligent managed part of the name comes in.
Right.
Exactly. This system is called fully network managed, which means it uses SNMP. That's the Simple Network Management Protocol.
Which is the standard language all enterprise gear uses to talk to each other, right?
That's the one. For the learner, SNMP is what allows for remote monitoring and this is the critical part, immediate remote alarm notifications.
That's the operational saving grace, isn't it? If an input signal suddenly drops, you get a digital tap on the shoulder immediately. No guesswork.
You know about it instantly.
Now, let's get to what I think is the most interesting feature here. PID modification. PID modification. That sounds like it's actually altering the video stream.
It is.
Why would a distribution amplifier, which is supposed to just pass things along, be messing with program IDs?
Because the DA is smart. A program ID, a PID, is basically the stream's internal identity tag. It tells all the downstream gear what programs and what metadata are inside that stream.
Okay.
By modifying the PID, this device can take a single input and then output two totally independent stream configurations.
So wait, you're telling me I can send the same physical feed to two different places, but have the box change the program IDs for each destination?
That's it.
So maybe one regional office needs certain metadata stripped out. This box can handle that internally, which is a huge operational win.
It is. It means you don't need another expensive upstream processor just to do some simple string customization. It's all in the box.
What's really fascinating is that all of this, the reclocking, the SNMP management, the PID stuff, it's all packed into a standard 1RU rack unit. BNC connectors, compatible with any DVB ASI stream.
Yeah, it's a lot of power in a small space.
So to wrap this deep dive up, we found that the Thor H-ASI-AMP isn't really a splitter at all. It's an intelligent strategic platform.
A management platform.
Yeah, it's focused on preserving quality through that reclocking and enabling complex workflows through the PID modification. You're buying strategic control, not just copper connections. And it's all backed by a 2-year warranty.
And building on that management idea, here's a final thought for you to explore. This device costs just under $2,000, right? $1,995. So considering those SNMP monitoring capabilities, what are the hidden, non-tangible costs like technician hours spent chasing phantom errors or damage to your reputation from missed airtime? What costs are saved purely by having intelligent network management that flags a problem the second it happens? The real value of intelligence often lies in the disasters it helps you avoid.